here's what I love about the show. It's not the explanation.
Besides,
it's the experiment.
for the myth to work, microwaves would have to cook from the inside out, and that's easily tested. Simply throw a roast in a microwave for 20 minutes and carve.
Look at that. I mean, it's totally cold on the inside. It's not heating from the inside out. It's definitely heating from the outside in. Yeah. The myth is totally busted.
Oh, so it's cooking from outside in.
Besides,
How's that possible?
Yeah.
Again, news for you guys. The microwaves, extremely high wavelengths, so they don't really penetrate that much into the body, and they don't penetrate that much into your food either. Depending upon the radiation, so proximity of the radiation source, penetration is going to be an inch, inch and a half. You're looking at a region which is about this small. So what happens within that region, if you got water molecules, they're going to start to spin. Spinning water molecules will cause vibrations that we know as heat, or we experience as heat, obviously. And then the heating is going to gradually travel inward. All right, so that's what's happening. So microwaves, extremely large wavelengths, they don't penetrate that much in through your skin. So we will make the same connection here. When you have a cell phone next to your head, and because it's right next to your head, yeah, radiation is going to penetrate through your skin into your brain, roughly about an inch, inch and a half. And now the frequency matters. For cooking, it has to be about 1 trillion cycles per second. So the next question is, what is the microwave cell phone frequency? Did they come near that value? So we'll take a look at it later.
The myth is totally busted.
All right, so when you have the radiation source next to your head, yeah, there's going to be a penetration in through your skin. So there's no question. All right, so go up in the electromagnetic wave spectrum, go up in frequency. Higher the frequency is, the smaller the wavelength becomes in this case. Now we end up hitting the infrared region. All right, notice that this is 1 trillion to 100 trillion cycles per second. All right, so if you can cause the charges to vibrate or randomly rotate within this region, that's experienced as heat or infrared.
Hyenas have excellent night vision. Surprisingly, so do goldfish. These fish see 4 primary colors compared to our 3. They also see an ultraviolet and infrared, the far end of the red spectrum of light. When we change the channels on the TV remotely, we're using an infrared beam. Channel surfing is fish hell. Infrared vision helps fish see in the dark as well as through murky water. We will never know how the world really appears to a goldfish.
Hey, you know what? We don't care, but here's what we care.
You use your microwave every day, probably without thinking about it. But tonight, we're going to show you again how it can cause a dangerous explosion in your kitchen. It involves a bizarre phenomenon. Before you use your microwave another time, you really must see what Chris Cuomo found in this Fun-Time Owner's Manual.
At about this time last year, Patty and Dave Long of Naperville, Illinois, were preparing for Easter.
It was Good Friday. The kids were off school.
Time to make Jell-O Easter eggs. Patty put the water in the microwave for 3 minutes to boil, but something seemed wrong. No bubbles.
So I hit the ad 30 seconds, and I stood and watched it. But it wasn't boiling, and I thought, well, it's got to be boiling. It's all right. Something has to be wrong.
Patty had been using a microwave for years. She was confused.
So I opened it up, and brought the container out, and I just kind of brought it down like this. So I was going to touch it with my right hand, and before I got my right hand there, I heard this like whoosh, and I got hit with all that water into my face.
It exploded.
It exploded like a bullet. It just hit the ceiling, too. There was no water left in the cup.
Patty had 1st and 2nd degree burns all over her face. Even worse, the corneas of her eyes had been scalded.
The whole eye was burned, and they were swollen on the inside, so it was blocking some of the vision because of the swelling inside the eye from the heat.
Were you afraid that you may have gone blind?
Yeah, I was afraid I'd never see my kids again.
It would take 6 months of treatment for Patty to fully recover her sight. Still, no one could explain what had caused this accident.
It really wasn't until I got home and saw the water on the ceiling that I really understood that something strange had gone on here, something that I'd certainly never heard of before.
People who have these sorts of accidents are probably reluctant to talk about them because it seems so bizarre and so unlikely. Who would ever expect water, the safest thing we can imagine, to come up and hurt us?
Let us show you what happens in slow motion. Water heated past boiling, more than 212 degrees, can erupt. Professor Louis Bloomfield, the University of Virginia physicist, says there's a simple scientific explanation for how these explosions can...
2 or above boiling without any bubbles forming. That's a phenomenon known as superheating.
Superheating.
Yeah, it's hotter than it should be for normal boiling to occur, and yet it doesn't boil.
Here's why. Something has to start the bubbles forming. Any little imperfection, like the texture of a metal pot, will do. So Bloomfield says, even though it may look unheated, it can actually be superheated.
Now, what does that mean exactly if water's superheated? It's just hot? How's that dangerous? Well, it's almost like a bomb once you've got it superheated adequately, because anything that triggers the boiling, once you've reached that temperature, will cause catastrophic, very sudden flash boiling. Now, can you test this? Can we show it? Well, we got a container of about half a cup of water here with some red food dye in it, and a little bit of fat floating on the surface, a little oil.
Like it were soup. We microwave the liquid on high power for about 3 minutes. There isn't a flash reaction every time, but this can be dangerous. Don't try it at home. Look what happened to us.
Ready? Let's go.
Bloomfield says all it can take to trigger an explosion of superheated liquid is for something like a fork to break the surface. Then, watch out.
Although an actual liquid explosion is rare, microwave makers put the warnings in their owner's manuals. They say to avoid the danger, stir the liquid before.
Yeah, I'm talking. So what's superheating?
When you heat a certain material past its boiling point, but it doesn't actually boil due to lack of imperfections.
Okay, Lucas, I'm gonna give you 5 points for that one. All right, superheating is heating water above its boiling point because nothing is breaking the surface tension, right? The water is not forming any bubbles. Okay, so according to the Virginia Tech physicist, the reason why the water is not forming any bubbles is because the inner surface of glass lacks imperfections. That's what he said. All right, so let's go along with what he said.
B.
Okay, so B, those of you guys who said B, give yourselves 5 points. Those of you guys who pick B, give yourselves 2 points for that one. Okay, so what happens when the water is superheated? Nothing is breaking the surface tension. Molecules are moving faster and faster on the inside, which means that the temperature is rising, the pressure is rising. And whenever you break the water tension, surface tension, it just explodes. All right, so this is what it is. All right, so superheating is heating water above its boiling point. So what happens is water becomes highly pressurized because nothing is breaking the water surface tension. According to the Virginia Tech physicist, this happens because inner surface of glass is lacking imperfections. Therefore, water is not forming any bubbles. That's what he said. All right, so this brings us to the next point. Next point is the same experiment done by Mythbusters. So here's what I love about Mythbusters.
It's time now for Adam and Jamie to investigate a microwave myth that is potentially lethal.
If you overheat water in a microwave, you may take the cup out of the bowl and then the water is going to explode in your face, injuring you or burning you in some horrific way.
We're going to time how long it takes to bubble.
After a little research, Adam and Jamie know that the only way water could explode is if it's being superheated, that is, heated beyond boiling point, without actually boiling. Tap water always boils because it has impurities. Distilled water has no impurities. That means no boiling. They put 2 cups of water in the microwave, 1 distilled, 1 tap. When the tap water boils, they'll know that the distilled water has become superheated. Just dropping in a sugar cube should make the boiling process happen instantly and violently.
Hey! Spectacular.
That would suffice.
That was exploding water?
It erupted. It left the container.
Yeah.
Quite a bit of it.
If someone were holding the cup, they would definitely have severe burns. But if straight tap water can't explode, how likely is it that people will be scalded by exploding beverages?
On your average day in your average house, it's not very likely. However, with the hundreds of millions of people using microwaves every day to boil water, reboil water, I'd say it could happen a few times a year around the world. Myth, absolutely true.
All right, so let's get back to the way they actually did the experiment.
It's time to
time how long it takes.
If it's being superheated, that is,
regular tap water versus
heated beyond boiling point, without actually boiling. Tap water always boils.
All right, so the conclusion is that tap water always boils.
Because it has impurities.
Because it's got impurities. Okay, so what are the kind of impurities that the tap water has? Guys, the one thing that I'm interested in, the dissolved gas inside. All right, so what happens to dissolved gas when you heat it up? It's going to expand. That's what the gas does. So it's going to form bubbles.
Always boils because it has impurities.
So unlike what the Virginia Tech physicist said, if you got dissolved gas, it's going to boil.
Distilled water has no impurities.
So distilled water does not have any impurities.
That means no boiling.
All right, so what does that even mean? How about the woman in Naperville? Remember what happened to her? The water ended up getting exploded on her face, went all the way up to the ceiling. What kind of water do you think they have over at Naperville? Naperville is set to be one of the best places where you could live, right? The water quality is so good in Naperville that you can literally get the water to explode on your face. These guys literally drink pure water. Is that what it is? I got news for you guys. You can take a dump in that water. I can still get it to explode on you. It's not a big deal. What's the problem? If you boil the water time and time again, what happens to the dissolved gas? It's going to escape at some point. At some point, you're not going to have anything on the inside. At that point, if you keep boiling it, you can superheat it. And so that's exactly what happened to the woman. Mythbusters at the end up making that point, but most people usually miss it because of the bad editing. All right, so you don't need to have distilled water. Regular water, once the gas escapes, it can still explode. It can still explode. Visible spectrum. When things are heated, at some point they will glow. So you end up getting light. So what generates light is the electrons jumping inside. This is known as the quantum jump. So the electron jumping inside the atom is going to emit light. which means that electrons jumping inside will just glow in essence. You can make that argument. All right, once again, the frequency range, this is 400 trillion to almost 800 trillion seconds per second. All right, if you go up into a higher frequency range, it's going to take you right into the ultraviolet region. So the electrical discharge, like lightning, is going to generate ultraviolet frequencies. Higher up the frequency is, the smaller the wavelength is, and the more it's going to penetrate into the body. All right, so now ultraviolet frequencies, ultraviolet can waves, rays, or whatever, they can penetrate through the skin. And just like beauty is, it's skin deep. So what happens within that region is it's going to cause aging. It can cause skin cancer, cataracts. On the positive side, though, it allows body to generate vitamin D. All right, so higher up we go. This time it's going to take us right into the X-ray region.
Oh, he's so busted. He's got issues. Nice pants. These things are amazing.
Introducing Docker's mobile pen.
I think they came up with this commercial maybe about 16, 17 years ago.
Port in Phoenix will be
Eventually that became technology that they're still using today at the
the first in the country to test this new technology. It's called Backscatter. It's been around though for a while, but never used.
X-ray backscatter. All right, so the X-rays are higher frequency, lower wavelengths. When you increase the frequency range within the X-ray frequency range, obviously the wavelengths get so much shorter that they will go right through the body.
Because people were worried about
All right, so this frequency range is adjusted just to go through their clothing here.
privacy issues. The TSA says it's found a way to refine the machine's images so that private areas can be blurred.
Not really, guys. They don't really blur the private areas for the obvious reason, because if you're going to be smuggling something, obviously you're going to be using your private areas. So if you're a guy, if you're sensitive about your size, just get a cucumber.
But bombs and other threats would still be detected. Passengers can opt out by choosing the traditional pat-down.
Good luck with that. All right. There are a couple of ways of generating it. One way of doing it, you got the fast-moving electrons, you just slow them down. Or deceleration, meaning that you're changing their direction. Frequency range is higher, obviously. Higher the frequency range is, smaller the wavelengths will be. The highest frequency range is the gamma ray range, right? The gamma rays are usually generated during a nuclear decay. And wavelengths are in the order of atomic nuclei, which means that they can destroy your DNA. You're looking at radiation poisoning. No, you're not going to turn into Hulk. You will turn into a cancerous mass if you're exposed to gamma rays. All electromagnetic waves, let's come up with a summary statement, are generated about the same way. All right, you got a charged particle just like that. You vibrate it up and down. So the vibration of charged particles is what generates electromagnetic waves. All right, so you go up between 10,000 to 100 million times per second, for example, it's going to give you the radio wave range. All right, so instead of vibration of charged particles or oscillation of charged particles, we say the accelerating charges is what generates electromagnetic waves. What generates electromagnetic waves?